Hello guys, today I'll start to solve some questions from past papers about the topic. I explained it in the last session. But before we start, let me tell you something very important. Please don't hate physics. Physics is not your enemy. Just if you understand everything, it will be easy for you. Let me know, please, if you have any problem in topics, difficult topics. If you have any difficult questions, just let me know. Just send a comment, and me or my assistants will start to answer your questions immediately. After that, I'll start to collect all these data and I'll start to explain the difficult topics for you. Only follow me, Lab Time Academy, in social media, Facebook, YouTube, Instagram, and TikTok. All of these things for free. Let's start. Okay, the first question from Cambridge, IGCSE Physics 0625, paper 43, October, November 2023. An irregularly shaped solid object has a density of 2.7 gram per cubic centimeter. I describe the method to measure the volume of the irregularly shaped solid object. As we said before in the last session, if you want to measure the volume of an irregular object, actually you have to use submerged method. You have to submerge the object underwater. First, I'll start to get a measuring cylinder and I'll pour a definite volume for water. I'll start to measure this volume of water, and then I'll add the irregular solid object in the measuring cylinder. What will happen? As we said, the water will rise up. So we have the second volume. Just subtract V2 minus V1 to obtain the volume of this irregular object. So here, 1, take a measuring cylinder and fill it with water. Note the initial volume, which is V1. This is the volume for the water. And then carefully submerge the irregular object fully in the water. Ensure no air bubbles sticking. Very important to take care about the air bubbles to get accurate results. Record the new volume of water plus object V2. And then the volume of the object, I have to subtract V2 minus V1 as we said. 2. He asked you to get the volume, to get the mass of the object, and he gave you the volume of the object, which is 83 cubic centimeter. All of you know that density equal mass over volume, rho equal m over v. So if we want to calculate m, we have to multiply, cross multiplication, mass equal density multiplied by volume. So here, density rho is 2.7 gram per cubic centimeter, and volume, which is 83 cubic centimeter as he gave you. Here we have cubic centimeter and cubic centimeter, so we will not convert any units. So the mass will be rho times V, which is 2.7 multiply 83 equal 224.1 gram. That's it. This question from Cambridge IGCSE Physics 0625, paper 4, variant 2, February, March 2019. First, define the acceleration. Let me tell you something very important. You know that we have from 2026 till 2028, we have new syllabus. So maybe the definitions will be different from the old syllabus. So take care about it. So here we have the acceleration. Actually, the acceleration equal velocity divided by time. So the acceleration is the change of or in velocity per unit time. B. Figure 1.1 shows the distance time graph for the journey of the cyclist. Here we have distance in meter and we have time in second. Okay. Describe the motion of the cyclist in the time between time 0 and time 15 seconds. Let's return back to the question from 0 to 15. So here from 0 to 15. So what will happen to this graph? Actually, we have what? We have increasing or decreasing or constant speed. As you see in the graph, we have curved upward. So we have increasing in the speed, means acceleration. So here we have increasing speed or acceleration. 2. Time equal 15 seconds and time equal 30 seconds. Let's return back here from 15 to 30. So here from 15 to 30. So we have just like straight line. So we have constant velocity or constant speed because we have distance and time. So we have constant speed. So here we have constant speed, as we said. 3, time equal 30 second and time equal 40 second. Actually, time equal 30 and time equal 40. Let's return back. Here, time equal 30 and time equal 40. We'll start from 30 to 40. So what will happen to this curve? It will be just like decreasing. So we have decreasing in the speed or deceleration. So we have decreasing speed or deceleration. Okay, double I. Calculate the 40-second journey. He gave you the time equal 40 seconds. Here we have the time. So this will be the time. He asked you to get the average speed. Average speed equal total distance divided by total time according to the new syllabus. So total distance from the graph till total time. So here we have total distance and total time. Total distance is what? Is 350. This will be the total distance. And here we have total time, which is 40. So here, just the total time or total distance divided by total time, V equal S over T. V is the velocity or speed, and S, which is the distance divided by time. So speed equal distance divided by time. The speed in our syllabus or the new syllabus, V or U. V, which is the final velocity, and U, which is the initial velocity. S represent the distance, not represent speed. Take care about the new syllabus. So S is the distance, not speed. Distance over time. So 300 over 40, as I said. So equal 7.2 meter per second. And this question has 2 marks. One for calculations and the other one for the final answer. And take care, you have to show your working. Don't write the final answer to get full mark. Don't write the final answer. 2, the maximum speed. Actually, you have this graph. As you said, we have distance and we have time. Distance in meter and time in second. He asked you about the maximum speed. So to get the maximum speed, you have to get the gradient of the most steeper line, steeper part, steeper region in the graph, the most steep. So the most steeper one, I think, start from 15 till 30, because we have straight line, as you see, right? So just start from 15 second till 30 second. In case of 15 second, what will be the distance? Just start to draw vertical line till it reaches the curve. And after that, horizontal line till it reaches the y-axis. So here we have 70. And also from 30 second, I'll start to draw perpendicular line or vertical line till it reaches the curve. And then get the time. It will be, or the distance, it will be 250. So at 30 second, the distance will be 250. Just get y2 minus y1 over x2 minus x1. So here we have 250 minus 70 over 30 minus 15 equal 12 meter per second. And don't forget the units. Don't forget the units. So 12 meter per second. So to get the maximum speed, you have to get the gradient of the most steep part, as I told you. This question from paper 4, variant 2, May, June 2017. Speed is a scalar quantity and velocity is a vector quantity. State how scalar quantity differs from the vector quantity. We said it before many times. Actually, the scalar quantity has magnitude without direction, while the vector quantity has both magnitude and direction. So here, scalar has magnitude and no direction, while vector has only magnitude with direction, has both magnitude and direction. Double line. Underline 2 scalar quantities in the list below. Actually, here we have energy, force, impulse, momentum, and temperature. So here we have 3 vector quantities and only 2 scalar quantities. As we said, scalar has only magnitude without direction. So we have what? We have energy, scalar, and also the temperature, which is the scalar quantity. So we have energy scalar quantity and temperature, which is the scalar quantity. B, a boat is moving at constant speed. Figure 1.1, sketch a distance time graph for the boat. As you see, we have distance on y-axis and we have time on the x-axis. Actually, to represent a constant speed, we know that we have to draw a straight line, start from the origin to represent constant speed. So this will be the answer. C, the boat in B is moving due to west at speed 6.5 meters per second relative to the water. The water is moving due south at 3.5 meters per second. In the space below, draw a scale diagram to determine the size and direction of the resultant of these two velocities. State the scale used. Actually, we said, how can we get the resultant vector of two vectors perpendicular to each other? We said we have two ways. We have two methods to get this resultant. Actually, number one, by drawing graphing scale, just use suitable scale. And after that, you can get the resultant from the graph, from the diagram, and use the ruler to get the resultant. The second thing, just by calculation, by using Pythagoras theorem. So here, let's return back. Here he said we have to draw the two vectors to get the resultant and use the suitable scale, because he asked you to get the resultant by graphing. He said the boat is moving due to west at a speed of 6.5. Actually, I'll start to use scale, which is 1 centimeter represent 1 meter per second. So here we have 1 centimeter will represent 1 meter per second. He said you have 6.5. The speed 6.5. Go to west direction. So here we have, imagine that the box has only 1 centimeter. So I'll start to draw 6 boxes connecting to each other. So here we have 1, 2, 3, 4, 5, 6. So this will be the first vector. So the first vector is 6.5. And this will be the direction. Take care. You have to draw the line and after that the arrow to represent the direction, because this is the vector. So here we have 6.5 meter per second. He said also we have the water. This is the direction of the boat. And after that, the water is moving due to south. So we have south direction to the boat is what? Is 3.5 meter per second. So I'll start to draw 1, 2, 3.5 till here. And I'll start to draw the direction. شيل الحتة الأخيرة دي اللي أنا قلتها. And I'll start to draw the direction. Right? After that, I have to get the resultant. Just draw the hypotenuse. Just from the tail of the first vector till the tip of the first vector, or till the tip of the second vector. This will be the resultant. From the tip of the first vector till the tail of the second vector. So this will be the resultant. So here we have 6.5 and he said 3.5. So we have 3.5 meter per second. This will be the resultant, or I can use a ruler to measure its length. By using the ruler, it will be 7.5 centimeter. That represents also 7.5 meter per second. This will be the resultant. Finally, he said we have to get or to measure the direction. This will be the angle. The angle between what? The angle between the resultant and the horizontal. The angle between the resultant and horizontal. Just use your protractor to measure this angle. It will be 28 degrees. So this will be the answer as we said. We'll start to draw the line or the vector to the west. And after that, draw another vector to the south. Here we have 6.5 and here we have 3.5, and after that you'll draw the resultant. Will start from the tip of the first vector till the tail of the second vector to get opposite direction. As we said, it will be 7.5 and the angle will be 28 degrees as we said. Here we have the scale, and also we have the size of the resultant velocity as we said, and this will be the direction of the resultant as we said. This question from paper 4, variant 2, February-March 2023. A. A boat across a river. The boat points at right angles 90 degrees to the river bank, and it travels at speed of 3.5 meters per second relative to the water. The river current acts at right angles to the direction of the boat points. The river current has speed of 2.5 meters per second. So we have 3.5 meters per second and we have 2.5 meters per second. By drawing scale diagram or by calculations. Thank you so much. So we have to choose as you like. You can get the resultant by graphing or by calculations. Determine the speed and direction. Direction means the angle between the resultant and the horizontal as we said. And the direction of the boat relative to the river bank. Here we have 4 marks for this question. Actually, I'll start to solve these questions by 2 methods to be better for you, to understand better. But you can choose only one method, as he said. First, here we are. So here we have 2 vectors at right angle. The direction for the river current and the direction for the boat. He said the direction for the boat is what? Is 3.5. So this is the direction for the boat. So let's start to solve it by graphing. Actually, I'll start to use suitable scale. I'll start to use that 1 meter or 1 centimeter represent 0.5 meter per second. Okay? So here, this means that we have 3.5 centimeter or 3.5 meter per second. So the 3.5 meter per second represent 7 centimeter. Why? Because we get this scale. 1 centimeter represents 0.5 meter per second. And the second speed, which is 2.5. And 2.5 meter per second represents 5 centimeter. And these 2 vectors, between them, 90 degree, right angle. So let's start. Here we have 7 centimeter. I'll start to draw 7 centimeter. So here, 1, 2, 3, 4, 5, 6, 7. So let's start from here. 1, 2, 3, 4, 5, 6, 7. So this will be the first vector, which is 7 centimeter. That represent 3.5 meter per second. And this is the direction or the speed for the boat. So here we have, this one is represents 3.5 meter per second. What about the second vector? We have right angle between them. He said here, the second vector has a right angle to the first vector. Yes, it will be 2.5 meter per second. That represents 5 centimeter. So I'll start to draw 5 centimeter. This will be the second vector. Okay, so here we have, this is the vector. Here we have 5 centimeter, which represents 2.5 meter per second. So 2.5 meter per second, as I said, represent the speed of the water, of the current water. And 3.5 meter per second represent the direction or the speed for the boat. After that, we can get the resultant. How can, as I said, just you have to close the triangle. So here, the resultant will be start from here to there. And take care, you have to draw the direction. So the direction for this opposite to the direction for this. Opposite directions to get the resultant. Just by using the ruler, just start to measure this resultant or this line, and it will be 8.6 centimeter. And actually, the resultant will be 8.6 centimeter. And this represents the speed, which is what? Which is 4.3 meter per second. So this represents 4.3 meter per second. So this will be the resultant. This is by graphic, as I said. After that, we want to get the direction. How can I get the direction? Actually, as I said, you can get the direction by measuring the theta, which is the angle between the resultant and horizontal line. So just by the protractor, you can measure this angle. It will be 54 degrees. So this is the first method to get the resultant by graphing. The second method, you can get the resultant by calculation. It's too easy. By Pythagoras theorem. Just right angle triangle and use the Pythagoras theorem to get the resultant. So that's it. We have 2.5 meter per second and 3.5 meter per second here. Let me choose this. So we have 2.5 meter per second and we have 3.5 meter per second. And after that, I'll start to draw to get the resultant R. How can I get it? R, which is the hypotenuse, equal square root for 3.5 square plus 2.5 square. It will be 4.3 meter per second. The same result we obtained it in the last topic or the last part. After that, I'll start to get this theta. How can I get the theta? Theta will be what? Tan negative 1. 3.5 over 2.5, opposite over adjacent, as I said, to get the tan. And then to get the theta, inverse tan. Yani you start to get the theta. How can just get the tan first? Opposite over hypotenuse. And then you get inverse tan, shift tan. And write this number, or 3.5 over 2.5, you obtain the same result, which is 54 degrees. So this will be the answer, ya shabab. This is the first method to get the resultant by using the graph. By using the graph or by graphing, you can get the answer. So get the R and also the theta. And this is the second thing, to get the Pythagoras theorem to get R. B, speed is a scalar quantity and velocity is a vector quantity. State the names of one other scalar quantity and one other vector quantity. Actually, we have many examples. Here we have the scalar quantity like mass, time, volume, density, energy, and distance. But the vector quantity like force, displacement, acceleration, moments, and momentum. Thank you so much, shabab, for watching my video, and see you inshallah in the next session inshallah. Assalamu alaikum.